Okay, so we're going to start talking about congruent triangles. Now, if we think about what it means to be congruent, it means equal measure. So, for example, I could say that angle A is congruent to angle D. That means that this angle here is the same measure there. So, if we have triangles which are congruent, it's the same thing. It's just that all angles and all sides are going to be congruent to corresponding parts. So, for example, with these two triangles, I have triangle ABC is congruent to triangle DEF. Now, the order here matters because I'm not saying that side AB is congruent to side DF. In fact, if you just look at them, you can tell that DF looks almost double, or at least double, the size of AB. So we know that they're not congruent. They are not the same measure. So, which parts are? Well, if I look here, I can see that I have AB and DE as the first two letters of each triangle. That means that side AB is congruent to side DE. I also have BC and EF as the last two letters. That means that BC and EF are two congruent sides. Similarly with AC and DF in the same pattern. I can do the same approach and read this the same way with angles. So I see that the middle angle, or the middle point, is B. The middle point here is E. So this angle E is congruent to angle B, much in the same way that angle A and D are congruent and C and F are congruent. Now don't just blow this off. This is very important, and here it may be simple and obvious, but when we look at some weird diagrams in the future, we're going to have triangles all over each other and rotated around and flipped. So by reading this in the appropriate way is a tremendous help. Also, we have this concept called Cpctc, meaning congruent parts of congruent, sorry, not congruent parts. I messed that up. Corresponding parts of congruent triangles are congruent. So what that means is this: corresponding parts, just like corresponding angles, they're in the same position. If I know that triangle ABC is congruent to triangle DEF, then I know that side BC is congruent to side EF. Those are what we call corresponding parts because they're in the same location in each triangle. And because the triangles are congruent, those corresponding pieces or corresponding parts must also be congruent. So this is a very key concept here that we will use a lot when we look at proofs. So let's look at some properties. So before we've seen the reflexive property, the symmetric property, and the transitive property when dealing with segments or angles. But now we're going to be dealing this with shapes, with triangles. So the reflexive property. Reflexive property, we actually don't even need this second triangle here because we don't deal with it. Reflexive property is all about one triangle being equal to itself. So the reflexive property is going to be triangle ABC is congruent to triangle ABC. It's reflexive. The symmetric property, well, the symmetric property is going to be if triangle ABC is congruent to triangle DEF, then we also know that triangle DEF is congruent to triangle ABC. We just switch them around. They're symmetric about the congruent side, so they just switch back and forth. And then we also have the transitive property, everybody's favorite. So this means that if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to some triangle here not listed, we'll call it GHI, then that means that triangle ABC is congruent to triangle GHI. We've been dealing with the transitive property a lot this year. Remember, it has to have this common link. So if 1 is equal to 2 and 2 is equal to 3, then we just get rid of the 2's and just say 1 is equal to 3. So that's a very important concept in dealing with and proving triangles being congruent. So reflexive, symmetric, transitive, same properties we've been looking at all year, so definitely pay careful attention to them. All right, so let's look at some problems here. So we want to show that polygons are congruent by identifying all congruent corresponding parts. And we want to write a congruent statement. A congruent statement, that is one of these. ABC is congruent to DEF. So which parts are congruent? Well, if we look, this side has one tick mark, as does this side. So that means that AB is congruent to, AB is congruent to DR. Now actually the important here matters because notice angle A and angle D both have one angle. So that means that A and D are congruent angles, so they have to be in the same order there. So we also have just found out that angle A is congruent to angle D. Which other angles are congruent? Well, angle B is congruent to angle R. And then we can also say that angle C is congruent to angle S. So looking at the other sides, I see BC. So BC is congruent. Well, notice if I go from B to C, and B is congruent to R, I must also go from R to S. And in fact, BC and RS have the two tick marks, and they both start with an angle that has the two arcs. And then we can also say that the remaining side is this AC. So AC is congruent to DS. So what would be our congruent statement? Well, you'd say that triangle ABC is congruent to, now I can't just say this in any order. I need to actually be careful and make sure that everything's in the corresponding part. So ABC, I need to go then DRS. DRS, and you can see that I'm going to congruent angles as well. For number 2, we can start with the angles. So we know that angle L is congruent to angle Q. Angle N is congruent to, well, I guess we should be careful. We should actually label that with 3 angles there. So angle MNL is congruent to angle PNQ. MNL, PNQ. And then we can also say triangle M is congruent to triangle P. We can see these outside sides are congruent. So we can say that ML is congruent to PQ, and also MN is congruent to PN. One last side, we can say that NL is congruent to NQ. So what would be the triangle that we would say? Well, actually, we have this angle here, MNL and PNQ. So we can say triangle MNL is congruent to triangle PNQ. And that's nice. All right, then we have polygon ABCD is congruent to polygon PQRS. Now we're mostly dealing with triangles, but this is actually a good problem to take a look at. So here we have find the value of x. Well, is this something we really need to take a look at now? Oh, no, it is. No, sorry. I was thinking of something else with parallel. ABCD, PQRS. This is a good drill in correspondings. So if we look at here, angle A, that's the first letter. So what about letter P? Well, it's right there. Ooh, so that means that angle 2x plus 4 is equal to 100. So if we solve that, we get that x is equal to, well, 2x is equal to 96. So x would be equal to half of that, which would be 96 divided by 2, 48. And then if we look at the value of y, well, it's this side here, DC. Well, DC or CD are the last two letters there, so that's going to correspond with RS, which we can see is 12. So we get 3y minus 3 is equal to 12. Add 3 to both sides, 3y is equal to 15, or y is equal to 5. Very, very important there. So watch out for corresponding. You can basically read these. We know that side AB is congruent to side PQ. We know that BC is congruent to QR. It's all in the order of how these polygons are written. And so that's why it's so important that we write them correctly. All right, so let's look at some other here. We want to identify the congruent triangles in these figures. So I see that J and T are congruent, so I can say that I can start off there. So J is congruent to T, P is congruent to V, so P is congruent to V, and L is congruent to S. So JPL is congruent to TVS. There we go. For number 2, we can do a similar approach and take this one angle at a time. And if we look here, we can see that Y has 3 marks, and that's congruent to C. B and X are the same, so X, B, and angle W is congruent to A. So YXW is congruent to CBA. This is tricky because these two triangles have a common side. But they can both start at this tip P. So P, we know that R is the same for both, so R. So PRQ is going to be congruent to PRS. Notice this triangle here and that triangle there. They go the different ways. And then we can do a similar approach here. So we know, writing this congruent symbol, we have triangle D, D. So D, angle D equals angle D. E and G are congruent. So E and G. And then angle F is congruent to angle F, of course. So DEF is congruent to DGF. So that's nice to look at. All right, name the congruent angles and size for each pair of congruent triangles. So same deal. So here we're going to have angle A is congruent to angle F. Angle B is congruent to angle G. Angle C is congruent to angle H. We don't even need to draw a picture. We can look at the sides in order. So I have AB and FG. So AB is congruent to FG. I also have BC and GH. So BC is congruent to GH. And then I have A and C and F and H. So AC is congruent to FH. PQR and STU. So I have angle P is congruent to angle S. Angle Q is congruent to angle T. And angle R is congruent to angle U. P and Q are the first letters, as are S and T. So I have, whoops, not an angle. I can have PQ is congruent to ST. QR is congruent to TU. And PR is congruent to, well, not S. Oh, too much. I'll write this over here. PR, the first and the last, is congruent to the first and the last, SU. And so those are the parts for those, the congruent parts. All right, let's write a proof, and that's going to end the lesson. So here we have a two-column proof. It's given that angle P is congruent to angle R. We know that PSQ is congruent to RSQ. So those two angles are the same. PSQ is congruent to RSQ, yep. PQ is congruent to RQ. And PS is congruent to RS. Well, let's start with the given. So angle P is congruent to angle R. Angle PSQ is congruent to angle RSQ. PQ is congruent to RQ, and PS is congruent to RS, and that's all given. All right, so number 2. Well, if I look here, look at that side, QS. That's a common side for both triangles, but doesn't it equal itself? So I can say side or segment QS is congruent to QS. And that's just the reflexive property. It seems obvious, but it's really important I say it because now I have, look at that, all three sides are the same. So if I can show that these two triangles have all angles congruent to each other and all sides congruent to each other, then the triangles themselves must be congruent to each other. So is there a way to show that angle PQS is congruent to triangle RQS? Well, sure. If I know that angle P is equal to angle R, and these two angles are congruent to each other, then these two must be congruent to each other. And that's the third angle theorem. Remember that from the other day? The third angle theorem says that if two angles in a triangle are congruent, then the third angle must be congruent. Well, now I can see that triangle PQS is congruent to triangle RQS because of what we said earlier. Cpctc, corresponding parts of congruent triangles are congruent, meaning all these parts are the same. Actually, that's, I don't know if I want to say Cpctc. That's not great. We'll use that later on. But here we could say that all parts in each triangle are congruent to each other. Which may be Cpctc, but we can write it like this. But if that makes sense, hopefully it does. So we have two sides are congruent to each other. The third side is congruent to each other because it's the same side. It's equal to itself from the reflexive property. And then the third angle must be congruent because of the third angle theorem, which we looked at in the previous lesson. So that's it for the proof. And we can show that these two triangles are congruent. Much in the same way, if we knew that these two triangles were congruent, we could show that the corresponding angles and corresponding sides were congruent. So make sure you practice with this. It can get challenging, and it will get more challenging. So if you can be familiar with the order and how to write these parts, it's going to help tremendously.